Hello and welcome back to Higher Maths Differentiation, looking at differentiating more complex expressions. So again, here we will need to rewrite what we are given in the question into a format that is suitable for differentiation. So example 1 here, differentiate y equals 1 over 3x root x. So we need to rewrite this here. So what is 3x root x? Well, 3x root x is 3x to the 1 multiplied by x to the half. And if we are multiplying powers together, as we know from National 5, we can just add the indices. So 1 plus a half is 2 halves plus a half, which is 3 halves. So the denominator here would be 1 over 3x to the power 3 halves. So what do we do next? Well, to differentiate, to get in a format suitable for differentiation, we must bring this up and make it a negative power. We cannot differentiate when there are x terms on the denominator of the fraction, the bottom of the fraction. Remember this large 3, if you like, that stays on the denominator. It's only x to the power that comes up. So that's x to the power negative 3 halves over 3. At this point, bring the power to the front, reduce the power by 1. So y equals y equals. At this point here, we are differentiating. So power to the front, negative 3 halves, multiplied by x to the negative 5 halves over 3. So negative 3 halves subtract 1 would be negative 3 halves subtract 2 halves, which would be negative 5 halves. That is where that power has come from. So at this point, we do top times top, numerator multiplied by numerator. So negative 3x to the power negative 5 halves over 2 multiplied by 3, which is 6. And then we can cancel negative 3/6 to negative 1 half. And we wouldn't write negative 1x to the negative 5 over 2. We just write negative x to the negative 5 over 2. And then the next line, x to the negative 5 over 2, well, we would bring that down to the denominator. So that would be negative 1 over 2x to the power 5 halves. And then back into a root format. So it would be x to the power 5 square rooted. So top number is the power, bottom number is the root. So it would be negative 1 over 2 square root of x to the power 5. So there is a lot of algebra in that one small question. So if you're going to have a problem with this, the problem will probably not be the actual idea of differentiation. The differentiation, you bring the power to the front, you're reducing the power by 1. The problem will arise with a misconception or a misunderstanding you might have from National 5. Okay, so we need to be very, very secure in those National 5 skills. You will get lots and lots of practice at doing it. Okay, but just beware, because if you're making one mistake over and over and over again, until you spot that you're making that mistake, you'll continue to do it. So please use my written solutions to help you guys. And get in touch if you need help, always. Question number 2, a bit nicer. So find dy dx when y equals bracket multiplied by bracket. So multiply out the brackets using FOIL. And then we have x squared minus x minus 6. So at this point, we're going to differentiate. So it was y equals, now it's dy dx equals. Please get your notation right. So power to the front, reduce the power by 1. So that'll be 2x to the power 1, which is just 2x. And we're differentiating minus 1x here, which will just go to minus 1. And if we differentiate a constant term, a number term on its own, we just get 0. So remember, before differentiating, the brackets must be multiplied out. And a note up here, you need to be confident working with indices and fractions. So that's your National 5 knowledge being applied here, guys. Right, I will do separate videos for examples 3 and 4.